This is PAT 2010, numbers 31 to 35, and numerical response 4, I hope. We have time. Okay, so this one is talking about electricity. Okay, and the question is asking about static versus current electricity. Okay, current would be the other kind. Okay, so let's take a look. Electrons can be discharged when clothes are removed from a clothes dryer. Okay, so when you have staticky blankets and towels and everything that have been in the dryer too long, yes, we can see the shocks that are created. Okay, electrons are discharged. Electrons flow continuously through a conductor, so they flow through a wire. No, that's current electricity. Okay, so not that one. Electricity can be used to operate a motor. Again, that's current electricity. Okay, electricity can build up and produce lightning. Yeah. Okay, so that's a big static electricity concept. Okay, so 1 and 4. 1, 4. Okay, so let's go with B. Next we have number 32, and we have an example of a wet cell here. So here's our voltmeter, our 2 electrodes that are showing to be zinc here, and we can tell already just by looking at the picture that this might have something to do with the question. They should be 2 different types of metal. Okay, one of them is usually copper. Okay, this is talking about how the electrolyte is 5% sulfuric acid. Okay, so your electrodes are the metals that are going to conduct electrons. Okay, and electrolyte is the liquid. And this is called a wet cell. So a dry cell would be our regular battery, okay, that we have. So this is a wet cell, okay? So let's see what the question says. What change could Roger make to the wet cell to produce electricity? We guessed it right away. Okay, change one of the electrodes to copper. Okay, which one says that? Replace one of the electrodes with copper. Awesome. Okay, but let's check what the rest of these are. Okay, would this increasing the concentration of sulfuric acid make electrons flow better? Yes, it would, if they were flowing at all. Okay, so that could be right if it was working. Replace both the electrodes with copper? No, because they have to be 2 different things. Decrease the sulfuric acid concentration? No. Okay, the more concentrated your acid is going to be, the more electrons are going to be able to flow through it. Okay. 33. What's going on in a hydroelectric power plant? Okay, so this is usually a dam. Okay, this is my fancy drawing where water is going to flow down. Okay, spin a turbine. Here's my fancy turbine. Okay, falls down the dam. Okay, which runs the electrical generator. Okay, so gravity is going to pull the water down. Which one says gravity? That one. Okay, then that's going to spin the turbine. So mechanical. Okay, which generates electricity and goes off to the power lines. These are my fancy power lines. Okay, so we have gravitational, mechanical, electrical. In 34, okay, it's asking when are the light bulbs going to shine the brightest? And it matters that these are in a series circuit. Okay, series circuit. So that means that everything in our system is going to have to share the electrons. Okay, going to have to share the snacks. Okay, the electron snacks. So let's say we have 2 bulbs. Okay, so that's not as many brothers and sisters you have to share your snacks with, right? If there's only 2 of you. Okay, so that's going to be better. Okay, they're going to shine the brightest. There's going to be the most electrons to go around in a 2 bulb system compared to having 3 systems, 3 siblings. Okay, now let's add in a resistor. Okay, something else like maybe a cat or a dog that are going to help eat your snacks. Okay, you don't want to share your electron snacks, your yummy electron snacks with anybody else. Okay, so if you don't have a dog, Okay, you get those electrons to yourself and you'll be brighter. You get more sugar. Okay, or chips or whatever you're having, or something healthy. Okay, so we don't want a resistor for us to be brighter. Okay, so without the snacks analogy, when you have a circuit, okay, if you have less items, less loads that need to use the electrons, okay, each individual item is going to be brighter. Okay, so 2 bulbs are going to be brighter than if you had 3 or more. Okay, so if you had 3 bulbs and a resistor, they would all be very dim. Okay. Question 35. Okay, comparing traffic to circuit diagrams. Okay, so which one is most like a switch? Okay, so switch closed, electrons flow. Switch open, electrons don't flow. Okay, construction sites, okay. Stop sign, vehicles, roads. Okay, roads would be like the conductor, that would be like the wire. Vehicles would be like the electrons going on the wire. Okay, I'm not sure what, this would be the whole system, the whole circuit. Okay, and then the stop signs, regulating whether you stop or go with the electrons. Okay, as it was going to be this one. Okay, I went ahead and pre-calculated these so you didn't have to wait. Okay, whenever you're calculating efficiency, just like how you do for a test, okay, you put what you got over what was on the test, how much you put in. Okay, so there was this many questions on the test, 10 questions on the test, you got 3. Okay, times 100. Okay, is 30% for this first one. Okay, and I went ahead and put these in the calculator. 16 on 71. 27 out of 100 we know is just straight into percent, 27. And then 510 over 950 is 54. Okay, so it's saying what is the most efficient, like 100% efficient, means all the electricity you put in is also output. Okay, do we have any hundreds? No. Okay, what's the next biggest number? 54. Most efficient. Okay, is number 4. Least efficient. Okay, the worst mark on the efficiency calculation, 23. So that's for device 2. Okay, and then 27 would have been 3 and 1. Okay, so most efficient, 54. Next most efficient, 30. Next most efficient, 27. Least efficient, 23.